Chapter 10.5 Expected Value. Now, expected value is last part of the chapter. So we are looking for it's an average gain. Okay, so let's look at the example. A $5 raffle ticket is purchased for a charity. If the charity is selling 2,000 tickets and the person holding the winning raffle ticket will win a prize worth $4,000, computer expected value for this raffle. So what you want to consider is all the possible outcomes and the probability of them. So say if you're the lucky winner, you win the grand prize $4,000. Now your actual winning though, okay, your expected win. Okay, you have to think about how much you're winning. So remember, you did pay $5 already. Okay, for this ticket. So your actual winning is 4,000 minus the five, so it's 3,995. Now a lot of people don't remember that. That's another outcome. It's called you didn't win, right? Which is negative $5. Okay, it's a charity, so we're donating $5. Now, what's the probability of each one? Now the probability of winning is one out of the 2,000 tickets, while probability of losing is the other 1,999 out of 2,000. Once you have this table set up, the expected value is just the outcome times its probability and the sum of them. So you take 3,995 times 1 out of 2,000 plus a negative $5 times 1,999, the other 1,999 ticket out of 2,000. When you do that in the calculator, you get negative 3. That means for every $5, every ticket you buy, you expect to lose $3 out of the five, value wise, on average. That means, I mean, you say, how can you lose $3? You don't. You either lose $5 or you don't lose, right? But we're saying in the long, if you do this raffle, like say, I don't know, a million times, okay, then the average one of these times you will win. So on average, that you will be losing $3. Okay. Now here's a similar another example, similar situation. In a game of roulette, a player can place $5 bet on number 17. Now, on number of if you bet on 17, you have 1 out of 38 chance of winning. If you win, you win $175. Again, if you pay $5 to bet, you win 175. Your actual winning is only 170. So the chance of winning $170 is 1 out of 38. Now there's a chance of losing $5, the other 37 out of 38. Same idea like the last time. You multiply the outcome and its probability and the sum of all of them, then you get the value, the expected value. So you expect to for every time you play this, you expect to lose because a negative dollar, lost 39 cents. Now if you play 1,000 times, then it just simply 1,000 times 39 cents. So you expect to lose $390. Now, same thing. This is slightly different, but the same idea. Okay, this is insurance payout. So so a 40-year-old man in U.S. has a 0.242% risk of dying during the next year. An insurance company charged $275 for the policy premium for $100,000 death benefit. So what is the expected value? So the outcome the outcome is what it's if you die, okay, then the outcome will be you get paid $100,000 minus the premium that you pay. So this is how much money you actually get, and the probability of that is very small. It's 2.242%. Okay, now so if you do the expected value, it's 99,725 times that. Now remember, there's a negative side of it, right? Even if it didn't show up here. Now if you didn't die, which is actually good news, but if you didn't die, that means you lost the $275 premium. And then the chance of that, now how do I get this number? If this is a chance of death, and this will be the chance of survival. Okay, so when you multiply this together, you expect to have a negative. Again, you expect to lose money. Well, yeah, it's insurance, right? So you expect to lose. You're hoping not ever use it, so you're expected. Again, it's actually negative.